Thinking about solar and wondering how to calculate your savings accurately? Here's the number one thing most people miss. While solar can save you money on kilowatt hour charges, it can't save you money on kilowatt charges or any fixed charges. If you're not familiar with the distinction between kilowatts and kilowatt hours, stick around. I'll explain it in plain English and what it means for your solar savings. If you'd like to see more videos from Solar Finance Simplified, please click like and subscribe. So here's the key idea. A kilowatt is a unit of power, or how much energy is flowing at any given point in time. A kilowatt hour is a unit of energy, or how much electricity flows over a given period of time. Think of it like this. Imagine water flowing through a pipe. Power, or kilowatts, is the size of the pipe, how much water can flow through at once. Energy, or kilowatt hours, is the total amount of water that flows through the pipe over a period of time. If I have a smaller pipe, it will take me longer to fill up a bucket of water than if I have a larger pipe. That's because more water can flow through the larger pipe at once. So the pipe is what determines how much water can flow into my bucket in a certain period of time. The size of the pipe is like electrical power, while the amount of water that flows through the pipe is like energy or electricity. Let's apply this to solar. Suppose you have two solar systems, one rated at 50 kilowatts of power and the other rated at 100 kilowatts of power. With full sunlight for an hour, and assuming our solar electrical systems are 100% efficient, the 50 kilowatt system would produce 50 kilowatt hours of electricity, and the 100 kilowatt system would produce 100 kilowatt hours of electricity. If we did the same thing for 2 hours, our 50 kilowatt system would generate 100 kilowatt hours of electricity, and our 100 kilowatt system would generate 200 kilowatt hours of electricity. You probably get the idea. A kilowatt hour is the amount of electricity that a 1 kilowatt system will produce over the course of 1 hour. This distinction between kilowatts and kilowatt hours is also important for understanding the charges on your utility bill. Many utility companies will charge you separately for the amount of energy you use and the amount of power it takes to deliver that energy to you. This is because it costs the utility company money not just to get the electricity to you, but to get you the amount you need in a given period of time. So each month, the utility company measures not just how much electricity you used, but the single point in the course of the month when the power or rate of energy flow was highest. So for example, your utility bill would look quite different if you used 1 kilowatt hour each hour over the course of 24 hours, or if you used 24 kilowatt hours all in the course of a single hour. The difference won't be in the price you pay for the total amount of energy. In both cases, you use 24 kilowatt hours of energy. The difference will arise from the amount of power it takes to deliver that energy to you. Let's go back to the water and the pipe in the example we discussed a moment ago. In this case, it's as if you're buying the same amount of water in either scenario, whether you get it over the course of a whole day or just in a single hour. But the utility company needs a bigger pipe to get you that water if you want it all in just a single hour. In some cases, you'll have to pay extra for that larger pipe. Let's calculate what this might mean for your bill. In the first case, where you're using 1 kilowatt hour every hour, your maximum power draw is just 1 kilowatt. But in the second case, your maximum power draw is 24 kilowatts because you needed all 24 kilowatt hours in the course of a single hour. Let's imagine that the utility company charges 10 cents per kilowatt hour and $10 per kilowatt. In both scenarios, you'll pay $2.40 for the electricity in kilowatt hours. But in the first scenario, you'll only pay $10 for power in kilowatts because you never needed more than 1 kilowatt of power to get the electricity to you. In the second case, you would actually pay $240 for power in kilowatts because you needed all 24 kilowatt hours over the course of a single hour. So your total bill for this day, if you use 1 kilowatt hour every hour, is only $12.40. But if you used all 24 kilowatt hours in a single hour, your bill would be $242.40. It would be unlikely to see such a dramatic difference in real life, but I used an extreme example to illustrate the idea. Let's take a look at an actual residential electrical bill to get a sense of how this works in real life. This is a sample bill from Eversource in Western Massachusetts. On the left, you can see the average kilowatt hours that were used each day for each month over the course of the year. Remember that kilowatt hours are electricity, or energy, which is like the water flowing through the pipe into the bucket. If we scroll down, we'll see that 1,036 kilowatt hours were used in the last month. And you can see that the charges here are actually broken up into two main types, supply and delivery. Supply charges are what it costs to produce the electricity that was used. Delivery is what it costs for the utility company to get that electricity to you. Let's take a look at each of these charges in a little more detail. The supply charge only includes a single rate per kilowatt hour of 10.47 cents. If we multiply that rate by the total amount of kilowatt hours used, which is 1,036, we get $108.47. The delivery charge is a little more complicated. It actually includes multiple rates per kilowatt hour and multiple rates per kilowatt. We don't need to know what all of these rates are for the moment, but the basic idea is that the utility company breaks out various components of what it costs to bring the electricity to you and charges you for them separately. If you look at all the kilowatt hour rates, which is for electricity, you'll see that each of them is multiplied by 1,036, which is the total kilowatt hours that were used that month. There are various charges here, including some negative rates, which are basically credits or adjustments for various public programs. If you look at the rates for power or kilowatts, you'll see that they're multiplied by $9.93 or $10.84. You can see that thankfully the maximum kilowatts or power for this month is pretty low at 2.5 kilowatts. That means there was some point over the course of the month when the utility company delivered 2.5 kilowatt hours of electricity over the course of a single hour. That was the highest rate of energy flow or power for that month. If we add up all the charges and organize them a little more clearly in a spreadsheet, it's easier to see how this works. Note that there's a customer charge at the top, which is just a flat fee that the utility company charges each customer each month, whether or not they use any electricity. After that, we have a whole list of charges. Most of them are kilowatt hour charges for various aspects of what it costs the utility company to bring you electricity each month. But two of these charges are kilowatt charges, one for transmission and one for distribution. We'll get into transmission and distribution in another video, but I hope this illustration conveys clearly what the difference between kilowatts and kilowatt hours means for your electrical bill. So what does all of this mean for your actual savings from solar? The key point is that while solar can reduce your kilowatt hours per month, it won't necessarily reduce your maximum power draw in kilowatts for each month. That's because your maximum power draw is unlikely to occur at the same time that your solar panels are producing energy. There are a few possible reasons for this. One is that most homes use more electricity in the evening, after the sun has stopped shining, when people return home from work. Another reason is that you may have a cloudy day, a system failure, a system shut down for maintenance, or some other factor that prevents your solar energy system from producing electricity at the point when it's needed most for those kilowatt charges. So even if you're looking at or already have a solar system that offsets a significant amount of your kilowatt hour charges, you shouldn't count on it reducing any of your kilowatt charges. If you live in an area where the utility company does not charge for power, then this won't be a concern. A final thing to note is that a battery can reduce kilowatt charges because many batteries can be programmed to deliver energy at moments of high power. That's one reason why solar and batteries together are such a powerful combination. If you found this video helpful, please hit like and subscribe, drop a comment or question below, and let me know what other solar finance topics you'd like to hear about. Thanks for watching.